Our planet Earth has been home to life for billions of years. From the moment the first single-celled organisms emerged in the primordial soup, to the complex web of life we see today, Earth has been a cradle of evolution and diversity. As we dig deeper into the fossil record, we uncover evidence of creatures stranger and more wonderful than we could imagine. Each fossil tells a story, a snapshot of life from a time long gone. These remnants of the past help us piece together the grand puzzle of Earth's history. Journey back with me to a time long before the dinosaurs, before even the first fish swam in the oceans. Imagine an Earth that was still in its infancy, a world teeming with possibilities and untapped potential. This is a journey to the dawn of complex life. We're going back 558 million years to meet the oldest known animal, Dickinsonia. This enigmatic creature with its ribbed, oval-shaped body represents one of the earliest forms of multicellular life. Dickinsonia is a window into a world that existed long before the familiar forms of life we know today. Imagine a world so ancient that the continents were in different places, and the very air we breathe had a different composition. The Earth's surface was a dynamic and ever-changing landscape, with continents drifting and colliding, and the atmosphere evolving in ways that would eventually support complex life. This was the Ediacaran Period, a time of immense evolutionary experimentation. The seas were filled with a variety of strange and unique organisms, each trying to find its place in the emerging tapestry of life. It was a period of trial and error where nature was testing the limits of what life could become. Life was evolving from single-celled organisms into more complex forms, and Dickinsonia was at the forefront of this incredible transformation. These early multicellular organisms laid the groundwork for the explosion of life that would follow in the Cambrian period. They were the pioneers, the first steps on a journey that would lead to the rich diversity of life we see today. The discovery of Dickinsonia fossils has provided invaluable insights into the early evolution of life. By studying these ancient remains, scientists have been able to learn more about the conditions of early Earth and the evolutionary processes that shaped the development of complex organisms. From the ancient seas of the Ediacaran period to the vibrant oceans of today, the story of life on Earth is one of continuous change and adaptation. Each chapter in this story is a testament to the resilience and ingenuity of life, constantly evolving to meet the challenges of an ever-changing planet. As we look to the stars and ponder the future of life on Earth, it's important to remember the lessons of the past. The history of life is a story of survival, innovation, and transformation. By understanding where we come from, we can better appreciate the incredible journey that has brought us to this moment and prepare for the challenges that lie ahead. So what did this ancient creature look like? Imagine an oval-shaped body, flat like a pancake, but with intriguing rib-like segments running across it. These segments grew from a central groove, giving Dickinsonia a symmetrical appearance. Now picture this. No eyes, no mouth, no legs or fins, just this enigmatic segmented oval. For decades, scientists were baffled by Dickinsonia. Was it a plant, a fungus, or something else entirely? Its strange shape didn't resemble any living creature today, making it incredibly difficult to classify. Some researchers even thought it might represent a completely extinct kingdom of life, unrelated to anything alive today. The mystery of Dickinsonia's true nature persisted for years, until a groundbreaking discovery in 2018. Scientists, using advanced techniques, were able to extract molecules from fossilized Dickinsonia remains. And what did they find? Cholesterol. Cholesterol is a type of fat molecule or lipid that is found in the cell membranes of all animals. Its presence in Dickinsonia fossils provided the crucial evidence needed to classify this enigmatic creature. Dickinsonia was indeed an animal, a very early ancestor to all the animals we know and love today, including ourselves. Section 4. Dickinsonia's seafloor ballet. Without legs or fins, how did Dickinsonia move? Recent research suggests that it may have moved in a way similar to modern-day earthworms. Imagine Dickinsonia slowly expanding and contracting its body, gliding along the seafloor in search of food. Scientists believe that Dickinsonia absorbed nutrients directly from the seafloor. It may have secreted digestive enzymes onto the microbial mats that covered the ancient seabed, breaking down organic matter before absorbing it through its body. It was a simple yet effective way of obtaining sustenance in the Ediacaran seas. Section 5. A window into the Ediacaran. The Ediacaran period, spanning from approximately 635 to 541 million years ago, marks a fascinating chapter in the history of life on Earth. This era, often overshadowed by the more well-known Cambrian explosion, holds its own unique significance in the evolutionary timeline. The discovery of Dickinsonia and its fellow Ediacaran organisms provides a unique window into a pivotal period in the history of life on Earth. These fossils, preserved in sedimentary rock, offer a glimpse into a world that was teeming with life forms that were unlike anything we see today. This was a time when life was transitioning from simple single-celled organisms to more complex multicellular forms. The shift from single-celled to multicellular life was a monumental step in the evolution of life, setting the stage for the incredible diversity of organisms that would follow. The Ediacaran fauna, with their strange and wonderful body plans, showcase the incredible diversity of life that existed during this evolutionary explosion. These organisms, with their unique and often bizarre shapes, represent some of the earliest examples of complex life on Earth. The Ediacaran period was a time of experimentation, where nature seemed to be trying out different body plans and lifestyles. This era saw a wide variety of life forms, each with its own unique adaptations and characteristics, as nature explored the possibilities of multicellular life. Although many of these early experiments ultimately went extinct, they paved the way for the evolution of more familiar animal groups, including the ancestors of all vertebrates. The legacy of the Ediacaran period is evident in the complex life forms that followed, as these early organisms laid the groundwork for the incredible diversity of life that we see today. The Ediacaran period's influence can still be felt in the modern world. The diverse body plans and lifestyles that emerged during this time set the stage for the rich tapestry of life that inhabits our oceans today. From the vibrant coral reefs to the vast array of marine species, the legacy of the Ediacaran period is woven into the fabric of life on Earth. Scientists continue to study the fossils from this period, uncovering new insights into the early history of life on our planet. Each discovery adds a new piece to the puzzle, helping us to understand the complex and fascinating story of life's evolution. Artistic renderings and visualizations of Ediacaran life help us to imagine what these ancient ecosystems might have looked like. These speculative reconstructions bring the distant past to life, allowing us to visualize the strange and wonderful creatures that once roamed the ancient seas. Modern technology has revolutionized the field of paleontology, allowing scientists to study fossils in greater detail than ever before. Advanced imaging techniques and 3D modeling provide new ways to explore and understand the ancient world, revealing the hidden secrets of the Ediacaran period. As we continue to explore the Ediacaran period, we gain a deeper appreciation for the complexity and diversity of life that has existed on our planet. This window into the distant past reminds us of the incredible journey that life has taken, from its humble beginnings to the rich and varied tapestry of life that we see today. Section 6. Dickinsonia's legacy. Dickinsonia may be long gone, but its legacy continues to resonate today. This ancient organism, which lived over 550 million years ago, has left an indelible mark on our understanding of life's history on Earth. Its discovery has fundamentally changed our understanding of the early evolution of animals. Before Dickinsonia was found, scientists had limited knowledge about the complexity of life forms that existed during the Ediacaran period. It tells us that complex life evolved much earlier than we previously thought, pushing back the timeline of when multicellular organisms began to thrive. This revelation has opened new avenues of research and has challenged previous assumptions about the pace of evolutionary development, and that the Ediacaran period was a time of extraordinary evolutionary innovation. During this period, the Earth was teeming with a variety of life forms, each experimenting with different body plans and survival strategies. Dickinsonia, with its unique ribbed oval shape, is a prime example of this evolutionary experimentation. By studying Dickinsonia and other Ediacaran fossils, scientists can piece together the puzzle of how early life evolved and adapted to changing environments. These fossils provide a window into a world that existed long before the age of dinosaurs, offering clues about the conditions that allowed complex life to flourish. We gain a deeper appreciation for the long and winding path that life has taken on Earth. The story of life is one of resilience and adaptation, with each organism playing a role in the intricate tapestry of evolution. It reminds us that we are just one small part of an interconnected web of life, stretching back billions of years. The legacy of Dickinsonia serves as a humbling reminder of our place in the grand scheme of things, highlighting the continuity and interconnectedness of all life forms. As we continue to explore the fossil record, each new discovery adds another piece to the puzzle, helping us to understand the complex history of life on our planet. The work of paleontologists is crucial in uncovering these ancient secrets, providing insights that can inform our understanding of current biodiversity and ecological challenges. We can be sure that there are many more wonders waiting to be discovered, hidden beneath layers of rock and sediment. Each fossil holds a story, a glimpse into a world that once was, and the potential to reshape our understanding of life's history, each one adding a new chapter to the grand story of life on our planet. The legacy of Dickinsonia is a testament to the enduring quest for knowledge and the endless curiosity that drives scientific discovery. As we look to the past, we are continually inspired to explore the unknown, seeking answers to the mysteries of our origins and the evolution of life on Earth.